Okay. The new lesson is quadratic functions and the quadratic equations. Okay. Quadratic functions and quadratic equations. Right. Now let's start the lesson. Okay. Here we have unit. Then all these things given in the unit. Okay. Right. Now it comes to the right, quadratic functions and the quadratic equations. Okay. Right. Then first part is a quadratic function. Right. First part is a quadratic function. Okay. Right. Now we need to know, right, what is a quadratic function? Right. What is a quadratic function? And what's the major difference of quadratic function and the quadratic equation? Okay. Right. So here we need to know that things because right they have two sections. And the importance of here, right? The importance of here is right. It's come to the right A-level paper question number 11. They have two parts, right? One of that, right? Factor theorem, remainder theorem, and algorithm, right? And the next part, right, contain the right quadratic equation and quadratic part, right? Then they have right two lessons, right? But most of the time it's they are given quadratic equation part, but some of the time we have quadratic equation things of the paper. Right? Very important. Because it was the question number 11, right? Easily we can score how to write 100, right? Percent of that. Okay, right? 150, right? No matter. Okay, right. Now, first of all, we comes to the right. Okay, definition of the quadratic function. Right, here is given a comma b and c are real constants and a not equal c. Then fx equal ax square plus bx plus c is called general quadratic function, right? Okay, right. Then what happened? Here we have a function fx, right? It's a ax square plus bx plus c. It is we called right a quadratic function, right? A quadratic function because why? Here, right, the degree 2, right, the highest power is a 2, then ax square plus bx plus c, be a quadratic function. Okay, right, then you know, a can't be 0 because a be a 0, right, here we don't have a quadratic, right, function. Okay, right, then others can be 0 and a, b, c are real constants. Okay, then that's a, right, quadratic function. Right, it's equal to 0. It's a quadratic equation. Right, it's a quadratic equation. Okay, right, that's the way that we get the quadratic function there. Okay, now the first thing is right perfect square of right, very important. Right, perfect square. So, what is the perfect square of quadratic function? What's the right perfect square of right quadratic function? Or we write the completing square, right? Completing square. Okay, right? Then, however, we write that in the whole, right? X plus some number square plus something, right? X plus k1 square plus k2 a form, right? Then k1, k2 are real numbers. Then what happened? They are a perfect square part. Then we call this part is a perfect square term. Okay, right? This is a perfect square term. Then however, we convert a square plus bx plus c into that, which we call the right completing square. Okay, this is completing issue, right? Okay, so what happened now? Now, here we need to follow some steps given in there. Let us follow the step given below. First one, making the coefficient of x squared, right? Making the coefficient of x squared equal to 1 in the quadratic function, right? They are given, however, take out the coefficient of x square and divide all the terms in the coefficient of x square. Right. Then what's the first step? Right. What's the first step? Right. We need to make right one x square there. One x square. Right. However, we need to remove a. Now, right, we need to careful because it's not a right equation. Right? It's not an equation, right? Then we can't divide all terms by a. Right? That's why we need to take out. Right? That's why we need to take out. Okay? First of all, we take out it. Right? That's a. Right? We divide all of that by the a. Okay? Right? Like that. When you take out the a, then we have x squared plus b over ax plus 3 over a. Right? Okay? Then the second one, write the variable term and the coefficient of its first power divided by 2, right? As a sum inside the brackets. Okay, right. Now they say what? Now we convert their coefficient of x square is 1 after we put the bracket and we get the variable term. Variable term means x. Right? Variable term is x. Why? Because here we write f of x. That means function of x. Right? That means function of x. Okay, then, right? Here we write x. That's a variable. Then we get the variable term here. It's a x and right here we have x. Then right, their first power. Their first power means x term. Right? Their first power coefficient. Right? Is a b over a. Right? Divide by 2. Right? B over a divided by 2. Right? Okay. First of all, we need to make the coefficient of x that is 1. Then after, we put the bracket, right, inside it, and we write the variable term, and also, right, their first power coefficient divided by 2. Right? With the addition. Okay? Right. Now what happens? B of a divided by 2. Right? We know if we have a two fraction division, right? Two fraction division, what happens? Denominator change the x and in there m and y. Then a come down, right? Here we don't have a denominator, it's a 1. Right? Then we have a b over 2. Then here we write it's a plus, then plus b over 2a. Right? Plus b over 2. Okay, then right. Then what happens? Right, that's the second step. Bracket and square is put outside the bracket. Okay, then we put the bracket and find the variable term and right their first power coefficient divided by 2 and put the outside square. Right? Put the outside square. Okay, then, now let's see what happens. Now let's see what happens. Here we consider first two terms and write this term. Then we get the expansion of that, right? Then we get the expansion. So what happens to expansion? It's a x square plus 2 times, right? B over 2a times x plus b over 2a square. Okay. Now what happens? Right here 2 and 2 cancel. Right here 2 and 2 cancel. Now we have x square plus b over a plus b over 2a square. Now these two already there. Right? But what happened? They are right, they have extra term. They have an extra term. Then, right, we consider something, write something there, right? They need to equal each other. That's why this is here. Right? These two equal. Okay, right? What happened? Here we consider the square that they have additional part. So we need to remove it because otherwise it's not balanced. Okay, right. So then they have cluster. Then we put the minus of that, right? We cancel it, right? Plus of the right. They are square. Then we put the minus of and c over a, right? And c over a. Okay, then right, we write like that. This we call the right completion, right? Completion. Okay, got it now? Okay, That is we call, right, completing square of the quadratic, right, function, right, quadratic function. Okay, right. Now what happens? Now here we have some simplifications, right? A times x plus b over 2a square minus here we get square. Now this minus outside always b square to 4a square plus here we have 4a square. When we multiply by 4a, then we have 4a, right? Okay. Then you can write the answer like this. Right? So we need to simplify there, but right, if they have right numbers, then we need to get the right answer of that. Right? So now what happened? Now we get right completing square of the right quadratic partial like that. Okay, right? That's the thing. Got it? Right? Okay, then we call this is the right completing square of quadratic function. Okay, now the same thing we need to follow the quadratic equation. Right, then they have one change, then let's see right what happens there. Okay, right. Now we have some examples. Y equal x squared plus 2x plus 3z. Right? Now what's happening here? Right? Now what's happening here? They have one x square. Right? One x square. Now doesn't need to anything take out because they are already one. So they put the bracket and write the variable x plus their first power is that their coefficient is 2. Right? Then 2 over 2 because right already anyone divided by 2 it's come to 0 value. Okay, right? Then 2 over 2 minus what happens? Here 2 over 2. Then we can simplify. We have right? Then we have 1. Then 1 is square outside plus 3. Now it's here x plus 1 square minus 1 3. Then it's here x plus 1 square plus 2 because minus 1 plus 3 is a 2. Now they have a perfect square. They have a perfect square. It's x plus 1 square. Okay, x plus 1 square. Okay, right? That's the way right we get the right completing square of. The next one, so y is equal minus 2x square plus x plus 3. Now they are given in the cube, okay, all the right. Now what happened? Okay, now they have the right coefficient of x square is a minus 2. Then we need to take out x minus, right? Then they have x squared only. Then minus 2 comes to the denominator and plus 3 minus half x minus 3 over 2. Right? They like that. Then what happened? So minus 9. Now it would be x and now they have minus half, then it's divided by 2. They have minus 4. Right? Then x minus 4 is square because here we have minus. Right? But we know here we have minus 4 plus doesn't matter. Finally we have they are square. It's always plus. Then we need to put the minus 1 over 4 minus 3 over. Okay. Now minus 2 times x minus 1 over 4 is square minus 1 over 16 minus here also we can multiply by 8 24 over 6. What happened? It's a minus 2 times x minus 1 over 4 square minus here minus both addition right 25 over 16 right like that. Okay, right? That's a way. We have another one. So y equal minus x square plus 2x plus 3. Right? Minus x square plus 2x plus 3. So here we have minus 1. Then we need to remove it. Right? Then minus x square minus 2x minus 3. Because we take out the minus, all the signs change inside it. Okay? Right. Then minus of put the bracket x 2 over 2 is 1 directly we can write is that minus 1 is equal to 1 minus 3. Here we have minus x minus 1. Right, right. Okay, ready? Now, this example given with you. Okay, right. Now we come to the right from examples, and we need to get the complete answer that. Okay, let's get this thing right. Okay, get the quadratic complete nature of that functions.